Hello everyone, welcome back. So, we are discussing the combined heat and moisture transmission phenomena related to clothing comfort. So, we are discussing now the clamminess sensation. So, here we are comparing with the two types of fibers, one is hygroscopic fiber like wool and hydrophobic fiber like polyester. Okay. So, in case of wool we have seen that wool actually delays the clamminess sensation because it absorbs moisture from the microclimate and it delays the clamminess sensation of wearer. That is, wool garment took up significant moisture, significant sweat from our skin as compared to polyester, and correspondingly subjects reported feeling less clamminess and warmer when wearing wool, because warmer due to the heat of soft sun than when wearing polyester during a period between 10 to 30 minutes. Warmer wool, one is due to the heat of soft sun, another is due to that it is not totally wet, okay. But polyester clothing, it does not absorb, it gets wet and the total conductivity of fabric also reduces. The length of the buffering period by the wool fabric and the magnitude of delay in humidity rise in the inside the wool fabric depend on the ability of the fabric to remove moisture relative to the speed of moisture development. So, if a person develop moisture at certain rate due to certain activity, if the clothing is able to absorb that moisture quickly, quicker than the generation of the moisture, he will feel actually dry, he will not feel clamminess. Okay. And this depends on the ambient condition. That means, if ambient humidity is less, that means the cloth will try to absorb, take out the moisture from the microclimate at faster rate. If the ambient condition is wet, it is saturated condition, that means the fabric, the fiber has already absorbed moisture from the environment. So, it will not be able to absorb from the sweat, from the skin or from the microclimate at that rate. So, it will delay. Clothing material and style, that obviously it depends on the fiber type and the type. Style means the style of the fabric, that means it is a design of fabric, style of the clothing, whether proper ventilation is there, whether it is a loose fit or tight fit. So, all these factors determine the buffering period and activity or intensity of exercise. So, if it is very active, its rate of sweat generation is very high. So, then in that case the moisture development will be different. So, the moisture flux across an inert porous medium, it is basically it is instantaneous, because porous and inert, I mean it does not absorb moisture, that means it works in, as we have discussed, it is a Fick's law, it is Ficky, and it flows through the only the pores, through the diffusion it goes, it is instantaneous, it goes immediately. But in non-steady condition, it may happen in case of say hygroscopic fiber. What it happens? It actually allows the moisture to transmit through the pores, as well as it absorbs, the fabric absorbs moisture and gradually it gets transmitted. So, that is we have already discussed this issue. Okay. Steady state, and most of the cases in hygroscopic material it is a non-steady case, because it in two way, for Fickian diffusion and non-Fickian diffusion takes place. Okay. During the transient period, that means initially when it keeps absorbing, it has not reached the steady state condition, the total amount of moisture removed from a high humidity microclimate, that means within our from the skin and clothing, that microclimate is greater with highly hygroscopic fabric such as wool. That is, the amount of moisture removed will be very high in case of hygroscopic wool material like wool than the weakly hygroscopic fabric, when hydrophobic fiber like polyester. Okay. In comparing wool and polyester clothing, the evaporation limit was reached later when the subject were wool garment, that we have already discussed, because wool absorb moisture. So, that means it the limit will reach later. Okay. And the perception of sweating and clinging sensation were delayed. That means, it will sense the clinginess or sweating in it will delay, it will after certain time, it is not immediate. Okay. That means, clamminess feeling, okay, you will feel at later time. So, if we see this picture shows where the surface temperature or skin temperature of a person who is doing exercise, okay, who is doing say treadmill walking. Okay. What is happening here? After certain time, when he starts his exercise, after certain time he will start sweating. Okay. In x axis this is the time, okay, and y axis it is a temperature of the outer fabric surface and temperature of skin. So, after sweating, the temperature of the garment and the corresponding skin was taken, and when it starts sweating, it has been observed that when the temperature at the cloth surface has been taken, it has increased suddenly, and that is for wool fabric. The wool fabric, it is the temperature suddenly shoots up, and that is due to that heat of absorption. But in case of polyester, it is almost flat, there is no significant change in that, and the same trend is observed in case of the skin temperature. So, this we can see here the dry heat transmission. So, skin temperature is also increasing, that is basically due to the increase in the fabric temperature. So, it is linked, okay. And when we see that when he is wearing a polyester, it is not increasing, that we have already discussed earlier, that exercise normally if a person do exercise, it does not change the skin temperature. Skin temperature only changes with the environmental temperature. So, but in this case during exercise the skin temperature increases, that is due to the increase in fabric surface temperature. And from that study, if we see the dry heat flux, and this is the total heat flux, and at bottom it is a evaporative heat flux. If we see the evaporative heat flux is almost same for wool and polyester. So, wool and polyester fabric it is almost same, because the heat evaporative heat flux is taking place, because he is doing the exercise in particular environmental condition, particular humidity condition, that is why it is giving the same evaporative heat loss almost. But if we see, it is interesting, the dry heat loss is high in case of wool, and in case of polyester it is almost same. It is whatever heat flux was there initially before the exercise and after exercise, even after sweating, sweating starts at this point. Now, when sweating starts, the evaporative heat loss is increasing, it is obvious, but why should the dry heat loss increase? Because as we have seen in the last picture, the dry heat, the temperature, surface temperature of wool fabric increases. As the surface temperature of wool fabric increases, the heat actual temperature gradient increases. So, that is the driving force for dry heat loss. So, dry heat loss increases for the fabric with hygroscopic in nature, and also the more the heat absorption, more will be the dry heat loss. Okay? And that effectively, if you see the total, this is the total heat loss for wool fabric, the total heat loss will be more. Okay? So, this is explained here, the liberation of heat by hydrophilic and hydrophobic fiber. For hydrophilic fiber, during exercise body temperature rises and the body start sweating for cooling it. Sweat will absorb by the fabric like hygroscopic wool fabric, and the temperature will rise due to heat absorption. Elevated fabric temperature increases with the body, stimulating higher skin temperature and rising the sweat level. That is why sweat level has increased, that is why evaporative heat loss is increasing. Sweat absorbed by the fabric further, further sweat will absorb, and dry heat loss we have already discussed. So, increase in heat absorption increases the dry heat loss at the outside of the garment due to the heat flux, temperature gradient. Hence, the body is able to release more heat during exercise. So, it is able to release a cost. That is why wool garment is used in sports textile just to actually release the more heat, dry heat. Now, if we see the hydrophobic fiber like polyester, the just opposite things happening. It is not able to absorb moisture, so its dry heat loss is less, and its total heat loss is also less, although the evaporative heat loss is almost same. The most of the sweat in the garment is present liquid, and it is a smaller, it has a smaller influence on dry heat loss. Therefore, the role of the clothing made from weakly hygroscopic fiber, hydrophobic fiber, is more passive, and its enhancement of heat loss during exercise is small. So, heat loss is particularly dry heat loss is small. Now, if we see the effect of environmental temperature, with the increase in environmental temperature, all the individual mechanism as we have discussed, driving force of heat like conduction, convection, radiation decreases, hence the heat flux decreases with the decrease in driving force, total heat flux decreases, and only phenomena is that evaporative heat loss at high environment. Now, if we see the effect of microclimate thickness. So, increase in microclimate thickness, that means a person is wearing a loose fit clothing, results in higher air layer causing increase in insulation and decrease in the following parameters. What are the parameters? The total heat flux and individual heat transfer mechanism. The total heat flux will reduce, moisture fraction at the inner and outer fabric will decrease, and temperature at the inner and outer surface will decrease. Because why temperature should decrease? Because of the thickness. The total fabric temperature is higher if the microclimate thickness is less, because the insulating air, it is insulating, because our its assumption is that our skin temperature is high, okay, and increase in air layer behave like a insulating material. Only thing is that the contribution of radiative heat loss, the radiation increases with the increase in microclimate thickness. That means, if our microclimate thickness is more, we are wearing loose fit garment, the air layer in thickness of air layer increases, that means air being insulating, that means thermal conductivity will be less, or if it is still air, that means thermal convective heat loss will be less, but the radiative heat loss is not dependent on the thickness of the air layer. That is why at higher microclimate thickness, the majority of heat loss takes place through the radiation. Radiative heat loss is prominent, and it is independent of microclimate thickness, while the fabric surface temperature is lower. So, that means radiative heat loss is more, in that case it is going in the wave form. So, fabric surface temperature is lower because of the thicker insulation. So, that is why it is outer layer or inner layer it is less. So, after microclimate thickness, let us see the effect, how is it related with the fabric thickness. So, as we know, the fabric thickness increase, if it is increasing, then its heat flux is decreasing, but it is less sensitive than the microclimate. As microclimate thickness, because in fabric there is a air layer and also in the material is there, but in microclimate only air layer, that is why it is less sensitive than microclimate, and the at thicker microclimate, thermal conductivity of fabric is higher than air layer between skin and clothing, that is microclimate. Change in fabric thickness from 0.5 to 5 millimeter, one study shows result change in total heat flux by 20%, that is a study report shows, and the effect which is important, the effect of thickness is large, that is if the microclimate is smaller. So, that means microclimate insulation is actually dominating factor. Now, we will discuss few parameters which are interlinked of heat and mass transmission. So, heat transmission we have seen there are various parameters like CLO and various parameters, TOG, thermal conductivity, thermal insulation, these are the parameters. And similarly, for moisture transmission we have seen there are various parameters, but there are few parameters which are actually very important, which are related with the combined effect. The most important is the evaporative transmissibility. So, the understanding is very important here. It is the indicator of the proportion of maximum evaporative cooling of sweat generated in a specific environment. So, maximum evaporative cooling means it consists of heat transmission and also mass transmission. Quantity of mass, quantity of moisture vapor transmission means it is proportional to the how much heat it will take. So, that is why evaporative transmissibility is very important, and it is expressed by the ratio of moisture vapor permeability IM to the dry insulation CLO. That means, if we take the ratio IM by CLO, which is actually which will give the parameter which is evaporative transmissibility, and two fabrics of same CLO value will give different evaporative transmissibility, and that will actually give us the actual comfort. A fabric with high dry insulation like flow value, if it can evaporate high value, higher moisture, if its moisture IM is high, that means the evaporative transmissibility will be high. So, that the ratio is a very good indicator of the comfort sensation. We can see, suppose two fabrics, one is of CLO 1, another is of CLO 2. Normally, we see that CLO 2 will give us very high insulation, but on the other hand, if we see evaporative, that is permeability, moisture vapor permeability index IM, if it is say 1:4, it is, if it is changing, then we will see the fabric 2, second fabric, which was very high insulating, at apparently it was looking at very high insulating, but due to higher permeability index it will give us very good evaporative transmission. So, that is the why the ratio is very important. Thus, the evaluation of insulation and moisture evaporative capacity of a clothing system is able to accurately estimate the relative advantage of clothing as compared to other. So, which fabric will give us actual sensation of comfort? Okay. If we assume the clothing, like for extreme cold climate, it is different, because there if we assume person is not sweating. So, in that case CLO may help, directly CLO will help, but when a person will start sweating, so in that case only CLO will not give the correct picture. There, in that case evaporative transmissibility is important. That means, insulation, the evaluation of the clothing, of the insulation and moisture evaporative capacity of clothing system is able to accurately estimate the relative advantages of clothing as compared to another with regard to thermal protection or strain when clothing is worn, that is thermal protective value. It is possible to compare material of different insulation value, we can actually compare. Okay. Evaporative cooling is less important when humidity is high and air velocity is low. Now, it is very important here. Now, if we use evaporative transmissibility as an indicator of comfort in very high humidity condition, then we may feel something wrong, misleading result, because in that case evaporative cooling is not there. So, in that case we will see the CLO value is giving indication. Okay. The evaporative transmissibility is helpful to compare the ensemble with different insulation value, as we have discussed. Two clothing ensemble with different thermal insulation characteristics, but same evaporative transmissibility would exchange same heat between the body and the surrounding in the same environment at the same activity level, that is important. So, in here the dry thermal insulation CLO value will give us misleading result. So, a person in activity and when he is generating sweat, in that case we should measure the ratio, and it is easy for clothing material with high evaporative transmissibility to transport heat by means of both convective heat transmission and evaporative cooling. So, this is the best indicator in high activity condition, but in case of environment with high humidity and at low air, as I have mentioned, the evaporative cooling is less important and the thermal transmission characteristics is more important in that case. So, and in case of that is high humidity condition, we can go for only thermal transmission condition. Next parameter is the skin wettedness. The skin wettedness is a parameter which is the actually it is a ratio of actual evaporative heat loss to the maximum possible heat loss. Okay. That is, the person is not wearing cloth. So, that ratio is there, and for completely wet skin it is a maximum value is 1, hot and humid climate. It is the wetness of the cloth in skin is 1, it is which is maximum value. The evaporative heat loss from the skin is a combination of evaporation of sweat secreted because the thermoregulatory control mechanism and the natural diffusion of water. So, that means the one is evaporation of sweat, another is natural diffusion of water vapor. So, both the vapor form and liquid it is coming in the vapor form. So, one is evaporation, another is water in vapor form it is getting transmission. So, transmitted that gives the total evaporative heat loss, and skin wettedness caused by diffusion is approximately 0.06. So, it is a very low value. So, only if we consider the diffusion it is 0.06. Okay. So, evaporative sweat secretion, that is heat loss is of with the two nature, one is the and another is the natural diffusion of water vapor, it is approximately 0.6. Now, for larger value of Emax, that is maximum evaporation, and longer exposure to the humidity, the value may drop to 0.02, that is the due to the diffusion it may drop to 0.2. That means, a person when is actually secreting in the moisture in the liquid form, and that means diffusion will reduce to 0.02. The out of 1 value it gives only 0.02 because the of the dehydration of the outer skin layer after diffusion characteristics. Okay. Skin wetness is strongly correlated with the warm discomfort. So, that means, if skin is wet, the person will normally feel the discomfort. Okay. For clothed subject, the W value is actually typically it is more than 0.2, more than 0.2 it is and perceived as uncomfortable. It must be below 0.2, otherwise the person will feel wetness. Okay. The skin will get wet, and if it is only diffusion, that means he is not wet, in that case it will be say 0.02 or 0.06, that is totally comfortable. That means, a person will feel comfortable when his skin is dry. Skin is dry means he is also releasing the moisture, but moisture transmission takes place only through diffusion. So, 0.02 or 0.06 or 0.07 below 0.2 it gives comfortable, and if it is above 0.2, that means the skin from dry to it is becoming wet. Okay. And theoretically it should be it is 1 means if it is totally wet, but it cannot happen, maximum it is 0.8. For all practical purpose the skin wetness is 0.8. So, if it crosses 0.2, that means we will feel uncomfortable. Now, coming to clothing ventilation. What is ventilation? That means, it allows the outer atmospheric air to penetrate inside and takes away the moist air from the microclimate. The clothing ventilation index is a quantitative evaluation which predicts the effectiveness, preference and suitability of clothing assembly. So, to ensure that the clothing is worn and used correctly. So, if it is used correctly, that means ventilation will be perfect. The ventilation index to improve the performance by minimizing the heat strain, sweat retention and thermal discomfort. The ventilation is vital to the removal of sensible and insensible heat. So, that will try to heat hot humid air will get removed from the microclimate. It is an important determinant of thermal comfort. So, better humid ventilation will give us comfortable but it is for particular humid particular condition. If it is extremely cold climate, then ventilation will give us discomfort. If it is hot and humid climate, then ventilation is required. So, we have to control the ventilation. So, the clothing ventilation is an evaluation method of microclimate at air exchange. Okay. So, microclimate air exchange. So, depending on the ventilation, it will actually determine the how much microclimate air will get exchanged. Okay. The factors influencing the air exchange are, because these are the factors which influence the air exchange, are air permeability of fabric. The more permeability, higher permeability means higher air exchange will be there. Design of clothing, we can design the clothing so that it gets better ventilation. Size of clothing, it is a fit, it is a loose or tight fit. Wind velocity, so higher wind velocity will have higher ventilation, and resilience of fabric. Okay. How the fabric gets actually come back from its deformed condition. Condensation occur within the clothing whenever the local vapor pressure rises to the saturation vapor pressure. Okay. So, saturated heat transmission will be there, saturated liquid precipitation will be there. In that case, the condensation will take place, and another case is that when the atmospheric temperature is low. So, in these two conditions, the basically the condensation take place. So, it is with the sweating skin model, this is called sweating skin model, which actually helps us in predicting the whether the moisture which we are releasing will get condensed within the fabric or not, and that depends on the vapor pressure and the temperature. The sweating skin model is used to determine the condensation in the fabric for both steady state and transient state. So, two different processes are there. One first process is the liquid water is injected close to the hot side of the sample and it evaporates there and recondensates in the cold side. So, that is the one procedure. Another procedure is that the hot plate is directly exposed to the moist air flow and transient temperature changes are monitored and the total amount of absorption and condensation is measured at specific time. So, from there when the at the hot plate the moisture is directly exposed, from there it gets evaporated and takes the latent heat and it also results the condensation. So, that is the principle of measuring sweating skin model, okay, the condensation measurement. Next is the it is a saturation line. So, this will give us the idea of the microclimate condition where we will start feeling wetness, skin wetness. This is the saturation line where in x axis is the temperature and y axis is the moisture vapor pressure, which means the pressure and temperature diagram of weighted air, that means weighted air means in the microclimate is used to record the condition of microclimate and study whether the condensation is formed on the inner surface of the fabric. So, the pressure P and temperature T diagram of weighted air is used to record the condition of the microclimate and study whether the condensation is formed on the inner surface of the fabric. That means, at certain temperature, if the vapor pressure say at the temperature is 30 degree Celsius, if the vapor pressure is it is at the as per the saturation line it is a 40, okay, 40 millimeter Hg. So, if the saturation line at this saturation line, if it is beyond 40 millimeter Hg, that means saturation will take place. The water content in the microclimate will increase, and on the other hand at the say 40 microclimate 40 pressure level, if the temperature is more, in that also will give us the that wetness, the degree of wetness in the microclimate. The saturation line is described as the water vapor pressure giving rise to the 100% relative humidity at the specific temperature. So, that if we have this idea about the saturation line in the, and if we consider in our microclimate, we can predict the whether there will be wetness or clamminess feeling or not. Okay. And condition of microclimate depends on the vapor pressure and the temperature. So, that is important. Vapor pressure means say relative humidity and temperature, and from there if we know that saturation line, we can predict the actual discomfort feeling of our clothing, and condensation occurs when the vapor pressure is saturated in microclimate. Okay. We will stop here with this, and next we will start the comfort related with the garment fit. Okay. Till then, thank you.